Material implication, a rule of replacement. If P then Q is logically equivalent to either not P or Q. Both sides of the four dots have the exact same truth table, and you can substitute either one in for the other at any point. This rule depends on the meaning of the conditional, which is that if P then Q means that in every circumstance that you have P, Q is also true. If you've got the antecedent, then you've got the consequent. This rule tells us that that means the same thing as saying, well, either P is false, you don't have your antecedent, or Q is true, because if you do have P, you've got Q as well. This rule is so powerful that some logic systems don't even include modus tollens, disjunctive syllogism, or transposition, because combined with modus ponens and commutation, this rule does all their work and more. To use this rule, switch the operator from conditional to disjunction, or from disjunction to conditional. Keep the order of the variables, and add a negation to the left side of the V, or remove a negation from the antecedent of the conditional. You'll have to use double negation to go from either P or Q to not P or Q if you want to get to if not P, then Q. We can use simple inputs to understand this rule, A and B. If A then B is logically equivalent to either not A or B. Adding not A as an input makes it a little more complicated, but if not A then B is logically equivalent to either not A or B. To use material implication to go from V to arrow, you need to have at least one negation on the left disjunct. Use double negation if necessary. With more complicated inputs, we can still use material implication. Let's sub in A and not B for P, and if not, it's not the case that if B then C for Q. Well, that'll read, if A and not B, then it's not the case that if B then C is logically equivalent to either it's not the case that A and not B, or it's not the case that if B then C. Note that since our Q input is negated, it's still negated on both sides of material implication. But since our input for P is not, it's only negated in the disjunction. In this rule, the main operator switches between arrow and V. The variables keep their order. A negation is added to the left disjunct of the new V, or subtracted from the antecedent of the new arrow. This never works on AND or biconditional. As a rule of replacement, it applies in both directions to any whole or partial line. It always cites one line and results in one line. Let's use our standard conditional translation to sort this out. If it is raining, then the ground is wet is logically equivalent to either the ground is not wet or it is raining. We might also say either it is not sunny or we go to the beach. Well, that would mean if it is sunny, then we go to the beach. We can use the truth table as well. It's particularly important since this rule doesn't look very intuitive, but we can see they've got the same truth table. True, false, true, true. We know that one for the conditional, if P then Q, since a true P leads to a false Q. That makes the conditional false. Meanwhile, in the disjunction, not P is also false, and Q is false. Both sides are false, so the disjunction is false. It gets there in different ways, but these have the same truth table. We can note the connection between material implication and transposition. All three of these have the same truth table. True, false, true, true. Let's see this rule in action. Here's a simple proof, very easy if we've got modus tollens. But what if you didn't? Well, you would need material implication. Here's how you'd do it. First, material implication for line 2, so that it reads either not A or B. You add a negation when going from arrow to V. Now we'll switch the order with commutation, B or not A, and add some negations with double negation, not B or not A. Now material implication again, we remove a negation and we switch from V to arrow. If not B, then not A. Well, we have not B after all, so we've got not A through modus ponens. Let's take a look at a more complicated example. If P, then not Q, and if not P, then R, and either Q or S. Therefore, R or S. Well, if you're on the lookout for which rules to use, we can see we've got conditional and something, and we've also got a disjunction. Maybe that's enough for a constructive dilemma? The only thing is we'll need to switch that V to an arrow and that arrow to a V. Well, material implication is the rule for that. So let's do line 1 first. Either not P or not Q. Now we'll have to apply double negation to line 2 to set us up for a material implication. If not P, then R, and not Q or S. Now we're ready. And we can do material implication on that partial line, giving us if not P, then R, and if not Q, then S. Now we're all set up for our constructive dilemma that's going to result in R or S. And just like that, this one's done. Let's take a look at a relatively weird proof. You'll want to pay careful attention to it, because it allows us to do something rather unexpected. If not X is true, then not Y is true. We know that from the premise and how the conditional works. Or that Y is true, rather. We also know that not Y is false, but here we've added it. Why will we be able to add it? Well, if not Y is false, then any conditional involving not Y is going to be true, because all conditionals with a false antecedent are true. So if not X leads to Y, then not X leads to any conditional involving not Y as the antecedent. It's more than a little odd, but it's a pretty important thing to be able to do as you do harder proofs. So the first thing we'll do is material implication, not X or Y. We've switched the arrow to a V, and we've added a negation. Now we'll use double negation, and we'll get not X or not Y, and a De Morgan's to get it's not the case that not X and not Y. Well, we've reached the end of things that we can do without adding Z. Fortunately, we have a rule for that. If you need a new variable, addition is the only way you're going to get it. So we've got it's not the case that not X and not Y or Z. If you want to get something from nothing, addition is your rule. And if you want to add an arrow from nothing, addition and material implication is your rule. Here we've changed that V that we just added into a conditional, and we've removed the negation. Now we can use exportation and get to our conclusion. If not X, then if not Y, then Z. We don't have any idea whether Z is true or false, and it doesn't matter since not Y is false. There's a number of common errors with this extremely important rule. Most of them involve mixing up negations or skipping double negation. So this first error is going from if not P, then Q to P or Q, and vice versa. That's true, but it's not exactly the rule. You've skipped a couple double negations in there, and that's important not to do. The next ones are worse. If P then Q is not logically equivalent to P or Q, you can't forget to add that negation or remove it. If P then Q is not logically equivalent to either not P or not Q, you can't add too many negations either. And finally, if P then Q is not logically equivalent to either P or not Q, you have to add it in the right place. Negating the old consequent is not going to work for a correct material implication.